everyone. This was our custom event.py which we created in the previous session. To save time, I have copied all its contents and I have modified the code a little bit in a modular format, and I have added a few more functionalities in it and saved it as catchfrenzy.py file, and everything is same, but I have modified it for more readability and all. So I'll explain you the whole code step by step. So let's get started. First things first, let us check out our custom event.py where we had a player class, we had three animations, we defined its initial values in init, we draw the window, we updated the code according to the animations, right? According to the events, we changed the animations and we displayed them in the update. Now, I had given you an assignment for creating a move left and move right functionality. For that code, I have added here. You can compare your code with mine and let me know your experience. Okay, so that was our player class. We also had a sprite class called as star sprite class, where we had a static sprite that was falling from sky towards the ground. Okay, so I have updated this sprite class inside catch frenzy, calling it as a star instead of star sprite. In star sprite class, we had provided image from outside. Instead, I have created a load image function in here itself where we can provide an image inside the star sprite class. Then inside the update of the star sprite class, I have created, when we want to reset the star sprite, I have changed its X position a little bit because it was like looking like the star is falling from the sky and it is going back at the same position from the inside the sky and falling it again. So I have changed its X position to vary the look and feel of the game. It looks like the stars are falling from different places every time and you have to catch them by moving your player. To collect the star, I have defined a variable self.collected inside the star class. Okay, when the star is collected, we are going to reset the star with a new X position, with a new Y position, and with a new speed of falling down. So initially our speed variable was having a name called as speed. So this time we have renamed it to speed y. Okay, and everything is the same, like you have draw function. Apart from that, this was our whole game code which I have complete and merged into a separate class called as a scene class, which again I divided into different functions like initializing the states like Pygame init, then displaying the caption, and then initializing the state like defining the window, then its different surface. I have removed, if you remember, I have removed the resizable part here. If you can notice here, I have defined a new variable self.life, self.gameover, and self.star count. Okay, this star count is the count of stars that we collect after the collision happens. Okay, inside the init, we have loaded all the images by calling their class files after the init state function is done, and then we have its own load assets function which will define our background, our foreground. I have added one more image as a foreground image just to make sure that player is looking nice and the falling stars are not going beyond the screen from the background. So they are going outside the screen but behind something. I'll show you how does this look. Then I have defined the player's position. Then I also have defined inside the player variable called as parent width, which is the width of the window. Then I have defined player's original X position and Y position inside the player class. And we have created two sprite objects from a star class and a similar bomb class. Now let me get back to the bomb class. We will check out the rest of the scene class after we have checked out the bomb class. Our sprite class is a static sprite that falls from the sky towards the ground. Our bomb class is a static sprite, but it also has an animation inside it. Okay, so we have added some more textures for blast inside the bomb class, and it also has a speed y, speed x, self dot collected, but it also has a functionality that we saw in player, that animation delay and all. We have created if there is blast playing variable to check out, because we want to see the blast should happen only once and the blast animation should stop. So for to control this thing, this functionality we have created is blast playing variable. Then just like the player, we need a frame index for blast as well. So we created a blast frame index here. And just like the player, we are going to again need a last update inside the blast as well. So we have created a variable for animation last update. Anim frame means which frame we are going to display. So self.blast texture initially 0. Then self.parent, where my bomb is going to appear, is going to be the parent. So in our case, our scene class is going to be parent for this bomb. Then current speed y. I want to randomize the falling speed. So I am using a new variable called as current speed y. The update method is similar to the star sprite, but there is one more functionality I have used here, that if the blast is playing, then we need to update the animation, update blast. Okay, so we can check out, this is the function for animation blast. We have done the same thing that we did inside the player. We have updated the blast frame and we have played the blast. But at the same time, we are changing the player's animation to animation idle after the blast is completed. Okay. Now, if you remember, I told you that I created a life variable inside the scene class. That life variable is useful when there is a collision between bomb and the player. We are reducing a life by 10. Okay, so whenever collision happens, we are reducing the life by 10. If the life is 0, we are playing the player dead event that we defined here, that we saw few minutes ago. Okay, so basically inside the update, we are checking out if we want to display the animation blast or if we want to reset the position of our bomb sprite. That is, randomly we will select an X position and Y position of the rect. We will reset its collected to false. We will update the speed and we will update the current speed. We are also going to vary the current speed a bit faster every time, just to check out, just to increase the difficulty of the game. And inside the reset functionality, we are going to reset the speed y to 5. Then we are going to reset the current speed to the 5 again. We are going to do self collected to false. We are going to reset the east blast playing to false. We are going to reset the animation frame index to 0 and animation frame also to 0. Okay. Then we have the normal draw functionality, but in this draw, we are going to check out if there is blast playing, then we are going to draw the animation frame. Otherwise, we are going to draw the bomb image. Okay. So this was our bomb sprite. Now let's just have a look of the remaining part of the scene class, where we have defined a render scene method where we were initially displaying the background surface self.window.blit. I've renamed it to self.surface.blit. Okay, I have again now we are drawing our player. Then we are drawing our, if it is game over, we are printing game over. Let's check out when the game over is happening. Okay. And if game over is not done, then we are checking displaying our bomb sprite, our star sprite, and our foreground. And in the end, we are updating our display by using display.flip. If you remember, I told you in the previous session, we can use display.flip instead of display.update because in display.flip updates everything on the screen. So we won't need to do each and every update for every class. Okay. Then let's go to the main loop. Inside the main loop, if you remember, we had the self.running, means it was initially running, but now we have declared it as self.running because we have put everything inside a class. We are checking out quit event. Then we are checking out our custom event, player dead event. In that case, we are going to play the animation to dead animation. Now, and if the player is dead, we are going to set the game over to be true. If game over is not true and bomb sprite is playing the blast, is not playing the blast, means if bomb animations, blast animation is not playing, then we are checking out our left and right button on the keyboard, the key down event. But I am also providing a facility to use the same left and right movement functionality with keyboard keys A and D. And on the key up event, we are playing the animation to be idle animation, just the way we did in previous session inside the custom event.py. Okay, the few events I removed from here are video resize because I wanted this window to be of fixed size, and the mouse events, those where we were changing the player's animation according to the mouse. Now, if you remember in the custom event, we were having the collision between the rect of player and the star sprite, right? Instead, we are going to use Pygame sprite functionality, which is collide mask. This helps us for pixel perfect collision inside two sprites. Since our player is also a sprite, our star is also a sprite, so we are using sprite collision method. So which is pygame.sprite.collide mask. If the collision happens between player and star sprite, what we are going to check is star sprite collected true. And after it is collected inside the update, we are resetting it to false. But once it is collected, we are increasing the variable that we defined above, star count, by 1. Okay. Later, we also, once it is done, we are going to play the animation catch. Okay. And in the same way, if the collision happens between player and the bomb, we are going to play the animation dead. But at the same way, we are going to do bomb sprite collected to the true, and we are going to play the blast animation if the collision occurs. Okay. And this ticks is equal to pygame time dot get ticks, that increases that checks out our That gives us our ticks, right? The current time. Then we are updating our player because we are going to update the animations after that flip has happened. If game over is false, then we are going to update our bomb sprite and star sprite. If game over is done, we do not need the bomb sprite and star sprite. We are just going to display the player. And in the end, we are going to render our screen using the render screen method where we have drawn everything on the screen. And we are going to run our loop according to our FPS that we want to be 60. For to update our clock cycle, we are going to use self.clock.tick to 60. More the FPS, smoother the animation looks. Okay. But now, if we want to display this scene inside our window, what we need to do is inside the main function, we need to create that scene. After that, we need to call its main loop, and in the end, we are going to use pygame.quit because if quit event fires, then we get to here. Okay, so let's check out how is our game looking. Python catch frenzy .py. A window has become a bit bigger, right? I'll move it little bit aside so that you can see the number of stars we are getting inside the terminal here. And if you can see, this is the catch animation when a star is collided with player. And let's see how does our dead animation look. Cool. I have provided all of the images inside the folder, resources folder, which you can use to create your own animation. Initially, we created a life of 30, which gets reduced after every bomb is collided with the player. So currently we are collided with two bombs. So that means our current life is 10. And what happens if we collide with the last one? We get here game over, game over, game over. Okay. So let's review the bomb sprite again. Just a quick review. I'm going to close this one to fire the quit event. And let's go to the bomb sprite. So when there was blast animation playing, we were displaying the blast. If there was no blast animation playing, we were displaying the bomb image. When there was a collision between player and bomb happened, we were animating the blast and we were reducing the life by 10. When the life went below 10, we fired a custom event, player dead event, which we caught inside this event, elif event.type player dead event, and we did player animation anim dead and self.gameover is equal to true. So this was our foundation for our game that we will develop later on top of this by adding some UI part like HUD and new instructions and having some music in it. So we will be using this same file for our further practicals. You can download this file, study it well, and let me know if you feel any doubts in it. Okay, so let's stay tuned for going into the UI part of the Pygame. Hello everyone, I welcome you to the fifth module of game development using Pygame. In this module, we are going to focus on user interface, also known as UI. So let's get started. Game UI, short for user interface, plays a vital role in shaping players' experience and interaction with video game. It encompasses all the visual and interactive elements that facilitate communication, provides important information, and allows navigate and control the game. There are a few key points. A good and a well-designed game UI. As first one is design. The visual game UI involves creating visually appealing and cohesive interfaces that align with the game's theme and style. It includes the layout, color scheme, typography, icons, buttons, and other graphical elements that contribute to the overall look and feel of the UI. Then comes the menu system. Game UI often includes menus that allow players to access different game features and options. These menus may include main menus, setting menus, pause menus, inventory screens, character customization screens, and much more. They provide a structured and organized way for players to navigate through the various game functionalities. Next is heads-up display or HUD. The HUD is a key component of game UI that displays important information directly on the screen during the gameplay. It typically includes elements such as health bars, ammunition counts, mini-maps, objective markers, and other indicators that provide real-time feedback and keep the players informed about their in-game status. Interactive elements. Game UI incorporates interactive elements to interact with the game world and perform actions. These can include buttons, sliders, checkboxes, input fields, and other interactive enable players to make choices, navigate menus, and control in-game characters or objects. Feedback and notifications. Effective game UI provides clear feedback and notifications to inform players about their actions, progress, and in-game events. This can include visual cues, audio prompts, text pop-ups, animation effects, and other form of feedback that help players to understand the consequences of their actions and keep them engaged in the game. Next comes on-screen prompts and tutorials. Game UI often includes on-screen prompts and tutorials to guide the players throughout the gameplay, mechanics, controls, and objectives. These instructional elements help new players to learn the game quickly and provide reminders or tips for the experienced players. Accessibility. Game UI should be designed with accessibility in mind, considering the needs of the players with different abilities. This may involve providing options for adjusting text size, colorblind friendly settings, customizable controls, and other accessibility features to ensure that a wide range of players can enjoy the game. Consistency and intuitiveness. A well-designed game UI maintains consistency in terms of visual style, layout, and interaction patterns throughout the game. This aims to be intuitive, easy to understand, minimizing the learning curve, and allowing the players to navigate the UI seamlessly. In conclusion, game UI is a critical component of any video game, shaping the player's experience and facilitating the interaction with the game world. It includes visual designs, menu systems, HUD, interactive elements, feedback mechanisms, tutorials, accessibility considerations, and much more. By creating an engaging and intuitive game UI Developers can enhance the player's immersion, provide a seamless user experience, and contribute to the overall success of the game. In this session, we checked out the introduction to game UI. In the coming session, we will see how to improve your game UI using custom fonts in Pygame. So stay tuned. Hello everyone and welcome back. In this session, we are going to discuss the font module in Pygame. Fonts play a vital role in creating visually captivating and immersive games. Pygame offers a dedicated font module that enables you to work with various fonts and enhances your text rendering capabilities. Let's delve into the font module in Pygame. The facilities that you can use in Pygame are loading fonts. Pygame provides the flexibility to load fonts from different file formats such as TrueType, that's TTF, OpenType, OTF. By utilizing the pygame.font.font function, you can easily load a font file and create a font object. Default fonts. Pygame also includes a set of default system fonts that you can readily utilize without the need for external font files. These fonts are specific to each platform and may vary across the different operating systems. You can access these default fonts using the pygame.font.sysfont function. Next comes font rendering. Once you have loaded a font, Pygame empowers you to render text using that particular font. The render function provided by Pygame takes the text string, anti-aliasing flag, text color, and optional background color as parameters. It returns a new surface containing the rendered text. Next comes text alignment. Pygame provides option to align the rendered text within the specified rectangular area. By combining the render function with the setAlign method in the font object, you can achieve left, center, or right alignment for your text. Next is text size and style. With the font module, you can control over the size and the style of the rendered text. You can apply bold, italic, and underline styles using the set bold, set italic, and set underline methods of the font object, respectively. Additionally, the set size methods allows you to specify the font size. Next is text matrix. Pygame offers convenient functions to obtain information about the rendered text, such as its width and height. By utilizing the size function, you can retrieve the dimensions of the rendered text surface, enabling you to accurately position and lay out the text elements within your game. Next comes system fonts. In addition to the loading external.font.get fonts, you can retrieve a list of available system fonts, giving you the flexibility to offer font choices to the players within your game. Text effects. Pygame empowers you to apply various effects in your rendered text, enhancing its visual appeal. Techniques such as text shadows, outlines, gradients, and textures can be used to make your text stand out and align with the overall aesthetic of your game. Custom fonts. If you have specific font that is not included in the system or bundled with Pygame, you can load and utilize custom fonts by providing path to the font file. This allows you to utilize unique and specialized fonts that align perfectly with the vision of your game. Next is text wrapping. Pygame incorporates functions to handle text wrapping, enabling you to display multiline text within a defined width. By utilizing the pygame.font.render with a boolean parameter for word wrapping, you can control how text is wrapped within a given space. Finally, international language support. Pygame's font module provides support for international languages and Unicode characters. You can effortlessly render text in different languages, include non-Latin scripts, and display special characters or symbols within your game. In conclusion, Pygame's font module offers a range of functionalities to handle fonts, render text, and apply various styles and effects. With the font module, you can create visually captivating user interfaces, display in-game text, and effectively communicate information to the players. Whether you are loading system fonts or not, you can use any of your favorite fonts to improve your player's experience. In this session, we checked out the font module in Pygame. In the coming session, let's have a look at customized cursors using Pygame. So stay tuned. Hello everyone and welcome back. In this session, we are going to discuss the cursors module in Pygame. So let's get started. The cursors module in Pygame provides a collection of predefined mouse cursor styles that you can utilize in your games and applications. It allows you to change the appearance of the mouse cursor to provide visual feedback or enhance the user experience. Let's explore the cursors module in Pygame. The first topic in cursors module in Pygame is predefined cursor styles. Pygame provides a set of predefined cursor styles that you can choose from. These styles include standard arrow cursors, crosshair cursors, resize cursors, hand cursors, and more. You can easily select a cursor style by using the predefined constants available in the cursors module. Next is setting the cursor. To change the cursor style, you can utilize the pygame.mouse.setCursor function. It takes a sequence of pixel data representing the cursor image, a hotspot position within the cursor image, and an optional mask for the transparency. By providing the appropriate pixel data, you can set a custom cursor style of your choice. Creating custom cursors. In addition to the predefined cursor style, Pygame allows you to create custom cursor images. You can use image editing softwares to design a custom cursor image, save it in appropriate file formats such as PNG or BMP, and then load it using the pygame.image.load function. Once loaded, you can set it as the current cursor using the pygame.mouse.setCursor function. Cursor hotspot. The hotspot of a cursor represents the pixel coordinates within the cursor image where the action is considered to be taking place. It determines the precise point of the cursor that interacts with the objects on the screen. When setting a custom cursor, you can specify the hotspot position to ensure accurate interaction between the cursor and the game elements. Next comes system cursors. Pygame also provides access to the system cursors that are available on the user's operating system. By utilizing Pygame.cursors module, you can access the system cursors such as default arrow cursor, text input cursor, resize cursors, and much more. This allows you to maintain the consistency of the user system and the cursor settings. Cursor visibility. Pygame allows you to control the visibility of your mouse cursor during the gameplay. You can hide the cursor using the pygame.mouse.setVisible false function and show it again by passing the true as the argument. This feature is useful when you want to hide the cursor during certain game sequences or provide a custom cursor that replaces the system cursor. Next comes cursor events. Pygame provides event handling mechanism to detect cursor related events. You can listen to the mouse movement events, button clicks and other cursor related events using the pygame.event module. This allows you to implement specific behaviors or action based on the user interactions with the cursor. Finally, cross-platform support. The cursor module in Pygame is designed to be cross-platform, meaning it works seamlessly on different operating systems such as Windows, macOS, and Linux. It ensures that your game's cursor functionality remains consistent across the various platforms, providing a smooth and unified user experience. In summary, the Cursors module in Pygame offers a range of cursor styles and customization options. Whether you want to use predefined cursor styles or create custom cursors, Pygame provides the necessary functions and constants to handle cursor-related operations. By leveraging the Cursors module, you can enhance the visual feedback, interactivity, and user experience in your games and the applications. In this session, we checked out the Cursors module in Pygame. In the coming sessions, let's jump into practical and let's work on the improvement of our UI. So stay tuned. Hello everybody. In the previous session, we checked out game UI and its significance in the process of game development. In the previous practicals, we created a structure for our games with basic animations, with some specific sprites, images, and event handling. In the current session, let's add a beautiful UI on top of our game. Let's start with a simple menu panel on the event of game over. For this, we are going to need a panel image which I have added an HUD board PNG in here which we will be using as the panel image. So let's get started. Let's open our folder inside our favorite code editor. We are going to build on top of our previous file catchfrenzy.py. So let's copy all the contents of that file into a new file and rename it to add menu panel.py. Okay. Quickly let's have a look how does our add menu panel file is currently looking. Python add menu panel.py. Okay. So I'm moving it a bit aside because we have to display our panel when the game over event is triggered, and you can see the game over event is triggered inside the terminal on the event of game over. Okay. So now for that, first things first, what we are going to need is we are going to need a variable that will control our menu panel's display and its timing. Okay, so for that, inside the init state of our scene, let's define these variables. Self dot show main menu is equal to false. Initially, let's keep it false. Then self dot menu counter show menu count show menu time, let's say time, easy word. Okay, show menu time 0. So as soon as game over happens, we will take some pause and then we will display the time menu panel. Okay, So for that pause, we are going to need some delay value. So self dot show menu delay. Let's call it 60. Okay. So we have created these three controlling values. Let's create a class for our menu above the scene. Class menu. Let's extend it with pygame.sprite. So let's copy the in extension part from the previous class, pygame.sprite.sprite instead of typing. Okay, menu is extended by pygame.sprite.sprite. Let's also copy some methods. Class method load images, CLS, its definition. Let's copy the init. We'll make the changes according our needs. Okay, for the class method load images, we are going to need load images. Let's call this texture as menu texture, and let's change the file name to hud board.png. Okay, inside the init, this time we won't send anything like texture, xy position, anything. We'll just say def init self. Now super instead of star, let's give it menu. Okay, super menu self init dash dash complete. Now self.image should be self.menu texture. Now our menu texture might be very big. So for that we are going to need to scale it down. So how do we scale images? Self.image is equal to pygame dot transform dot scale. What do we want to scale? Self dot menu texture, and to what dimensions. Let's scale that image a bit down. That should fit inside our game screen. So let's do width into 0.75 and height into 0.75. We are scaling it down to this value so that we can also see some part of our main screen and some part of and our whole menu panel as well. Okay. Now we need to define the self.rect. For that, what we are going to need is self.menu texture dot get underscore rect. Cool. Our menu panel is not falling, so we are not going to need this. But now we are going to need a position for our menu. So self dot x is equal to, let's put it at the center of our screen. So width by 2, self dot y is equal to height by 2. And we are also going to need x and y position for our image of the menu. So self dot rect dot x is equal to, let's put like width into 0.1, so that it won't start exactly at the corner and it will also stay inside the screen. So let's do that. Width into 0.1 self dot rect dot y is equal to height into 0.1. Cool. Now we have defined the init. Let's just define a draw here. Def draw. What do we want to draw? Self. And what surface? Let's say some surface. Okay. And surface dot blit. What do we want to blit? Self dot image in self dot rect. That's it. So what did we do? We defined a menu class with its load image, init and draw method. We defined some controlling variables inside the init state. Now let's instantiate our menu class as first thing loading images. Menu dot load images, and inside the load assets let's instantiate as self dot menu is equal to menu. If you remember, we did not provide any other parameters to menu. We just provided a self here. This is okay. So instantiating will be enough. Now we have instantiated it, but we want to draw it. So how do we draw? Let's go to the render scene. We want to draw it when there is game over. But let's have a little more control. So if self dot game over and self dot show main menu, in that case only we will do self dot menu dot draw. And where do we want to draw? On the self surface. Self dot surface. Okay. Now initially we have our show main menu to be false. Now we need to make it true. So where do we want to make it true? Let's go to the main loop. Here in the end we have checked if self dot game over is equal to false. Let's put an else here. Else self dot show main menu is equal to true. Okay. Now let's try to run it. What happens? Python add menu panel dot py. I'm sorry, there is an error in line number 224. In our draw method, I guess. Yes, there is a typo. Okay. We saved the file. Okay. I'm going to collide with bombs only so that the life is going to get over as soon as possible, and we will see the menu panel. Cool. But what happened? We didn't see the whole animation of the player on the last time. So for that, we are going to need some time between the menu panel and the animation. So for that, we are going to use these controlling variables self.showTime and self.showMenuDelay. So where our custom event is triggered, the game over event, let's start increasing self.showMenuTime plus equal to 1. Let's start increasing it here. And when the game is over, let's check if self dot show menu time is greater than or equal to self dot show menu delay. In that case only we need to make it true. And let's do one thing. Let's reset it here instead of increasing. Show menu time is equal to 0. Okay. And let's increase it at the game over place. Self dot show menu time plus equal to 1. So every clock cycle, if there is game over already true, this will increase the show menu time, and once it is completed, it will show our main menu. So let's run it now. Did we save the file? No, we didn't. Okay. 1, 2, cool. We got some delay between our player and the panel. So this was our first UI practical. In the coming session, let's add a restart button or replay button or play game button, one button itself that will help us to get the restart functionality in our game. Okay, till then, stay tuned. Hello everyone and welcome back. In the previous session, we checked out how to create a menu panel inside our game. In this session, let's add a start button which will also serve as a reset button or restart button inside that menu panel. Okay, so let's get started. For our requirements, I have already added two new images in our folder. So let's open our folder inside our favorite code editor. We can see we have our previous file already opened inside the code editor. Let's copy the contents into a new file and save it as add menu button dot py. I'm going to the terminal a bit smaller. Okay, so quickly let's review our code. We have a player class, a bomb class, and a star class. For the button, we are going to display it on the menu panel, so we don't need to work on player, bomb, or star. We need to work only on the menu class and the scene class. Okay, so for this functionality, what we are going to need is to load images for our button, to set their position, and to draw them on the screen. And finally, the we need to catch the click action of the button. Okay, so let's get started. First things first, let's load the images. cls dot play textures equal to, we have two images, so I'm going to use array and I'm going to use the same functionality to load the image that we used to load our HUD board. Here start.png, comma, pygame.image.load, start pressed, .png, convert alpha. This is how we load the images. Now we need to define a position for the image, right? So self inside the init of the menu, self dot play button rect equal to, we need to correct the indentation, self dot play textures of 0 dot get underscore rect. Okay, and we need to set the position of this rect to be at the center of the screen. So self play button rect dot x equal to high width minus self dot button play button rect dot width divided by 2. This is how we calculate the center x of our screen, and similar way we calculate the center y. Center y is equal to height minus self dot play button rect dot height by 2. Okay, so this is how we define the place where we are going to display the button rect. Now to display different images, we need to make the state of the button. So we need a one more variable, self dot play button state equal to, let's say, normal, and what will be the other one, pressed. Okay, we have loaded the images, we have defined the position and the state of the button. Now let's draw the button. Okay, so if self dot play button state equal normal, then we need to draw surface dot plate self dot play textures first image, the zeroth one, where in a tuple of self play rect x and self play rect y. Okay, this is how we draw it. We will be able to see it once we run it, but before that we need to capture the touch event or the click event on this button. So we need to go to our event loop inside our game loop. What we need to do when the button is clicked, we need to reset the game because our menu is going to get displayed after the game over. So for this we have written a reset game functionality previously. Let's check it out. In the reset game, we are resetting the life to 30. We are resetting the player's animation to idle. We are changing the game over to false so that we can play again. We are resetting the player's position, the XY position. We are resetting the star count to 0, and we are doing the bomb sprite dot reset function. Okay, so this is our reset game functionality, which we will call on button pressed of this play button. Okay, so let's go inside our game loop. Here, if game over is not equal to false, so if game over is equal to false, what we are doing? We are checking the player movement key related functions, keyboard related events. But if game over is true, we need to check out the mouse events. So elf event dot type equal pygame dot mouse button up button down. Okay, and if event sorry no if self dot menu dot play button rect. If you remember, we checked a method inside the rect pygame.rect slides that there is a collision method, right? For if a point is inside the rect, we are going to do the same here. Collides collide point, which point? The mouse position event dot pose. In that case, what we need to do is we need to change self dot menu dot play button state equal to pressed. Okay. Now have we checked what happens if we have displayed play button state? We have used only normal. If it is not pressed, we need to change it, else surface dot blade other texture. Surface dot blade texture number 2. Sorry, texture play textures of 1 means texture number 2. Okay. On the mouse down, we are changing the state. Now, if elf event dot type equal pygame dot mouse button up, same functionality. If this mouse position is inside the buttons rect, we need to do is self dot menu dot play button rect play button state equal to normal and self dot reset game. Okay, then now we did all the things. We loaded images, we defined positions, we drew the buttons on the surface, and we got the events. Let's try to run it. Python add menu button dot py. Let's quickly proceed to game over. Okay, game is over. Cool, button is displayed. What if I go to the button, I press my mouse down, the button is changed, right? And now when I leave it, the game is reset. Cool. This is how we add a button in Pygame and access it. So in the coming session, let's add a title to our menu panel. Okay. So stay tuned. Hello everybody and welcome back. In the previous session, we added a button in our UI panel. In this session, let's add the game title in our UI panel. Okay, so let's get started. For this, we are going to need a font file for us. So I have added it, the comicrelief.ttf file in our folder. Let's open our folder inside our code editor. Now, this is our previous file, add menu button. We will use the same file to work on top of it. So, let's copy all the contents in a new file. Let's save it as add title.py and let's paste the contents. This time also, we don't need to work on any other classes. We just need to work on the menu class. Okay, so let's go to a menu class. Inside the init method, what we need to do is, first things first, we need to load our font. Okay, so let's define a font, but for that font we are also going to need a font size. So let's define the font size. Self dot title font size, let's say equal to 30. Okay, then self, let's define the font now. Self dot title font equal to pygame.font.font. Pygame.font.font. Which font? The comic relief font we have. Let's copy the name from here. Let's paste it here. And we also need to provide the font size. Self dot title font size. Okay, this is how we loaded the font. Now we need to define the title string for our title. Okay, so self dot title is equal to self dot title font dot render. What do we want to render? Catch frenzy ninja edition. Okay, now we want to initialize it, so we will do true comma, and what color do we want to display it? Let's say white. 255 comma 255 comma 255. Okay, now we need to define the position of the title on the screen. How do we do that? Self dot title width is equal to self dot title dot get width. Same for height. Now we need to define the rect for it. Okay, so self dot title underscore rect is equal to, we need to now define a Pygame rect. Pygame dot rect. Where do we want to put it? Let's say width into 0.2, comma, height into 0.25 inside. Then we need to provide the height and width of the rect. Self dot title rect, title width, comma, self dot title height. Okay, this is how we define the rect for our title. Now we need to just draw the title. So how do we draw it? Simply by the same way how we draw the images. Surface dot blit self dot title, comma, self dot title rect. And that's it. This is how you display some text in Pygame. A simple text but custom font. So let's try to run it. Python add title.py. Our menu is going to be at the game over. So let's make the game over. Cool. So this is how we add text with custom font in Pygame. In the coming session, let's add some instructions in our game. Okay. So stay tuned. Hello everyone. In the previous session, we added the title of our game to the menu panel. In this session, let's add a multi-line instruction inside our menu panel. Okay. For this, we are going to use the same font that we used for the title. So we won't need any new file to get loaded inside the game. So let's just get started by opening the folder inside the code editor. Since we are displaying now instructions, we need to show our main menu at the starting of the game. Okay. For this, we will need to make changes inside our scene as well. So we are going to build on top of our previous file. So let's just copy all the contents of the previous file in a new file and let's save it as multi-line instruction.py. Okay, let's close the add title.py. Let's do the necessary changes for the scene class first. Okay, currently our main menu is getting displayed on the game over itself. But now we want to display it as soon as the game is loaded. So self.gameOver is already true and self.showMainMenu is also true. Okay, and inside the reset game function, let's convert self.showMainMenu equal to false. Okay, we are done with the scene class. Now let's go to the menu class. In the previous session, we added the text by creating a font size, then a font, and then defining a rect of the font. We have to do the same process this time as well, but since it is a multi-line text, we need to do a little more functionality. So let's do one thing. Let's copy the common things, those we are going to need. Okay, so first things first, let's copy the font. Why are we copying it? Because we are going to need different font size for the instruction. I'm going to say write self.inst font size, let's say 28. Okay, now self.inst font, same font but with the inst font size. Okay, now we need to define our text that we are going to display with the instruction. So self dot inst underscore lines equal to, what are the lines? Use A and left to move left. Use D and right to move right. Also collect the coins and stay away from bombs. Okay, that is our text. Now let's correct our indentation. Okay, now what we need to define is a good amount of length for displaying our text. For this, let's define a string that we may or we may not display, but we need that length. Okay, so self dot instruction is equal to self dot inst font dot render. What do we want to render? Let's add these two lines together so that we get enough space to display our lines. Okay, then comma true because we want to anti-alias it and we want to display a color for it. So this time let's go with yellow color. 255 comma 255 comma 0. Okay, we can define the color code in constants as well. You can use those as well. Now self, because we want to display the lines one below another, we are also going to need the line size. So self dot line size is equal to self dot inst font dot get line size, display the lines. So self dot line x equal to width by 2, and I want to display it a bit lower side. So self dot line y equal to height. I'm going to display it to 4. Okay. Now what did we do? We loaded a font, we defined its font size, we defined a good amount of length for our rect, we defined the line size for our lines. Now we need to draw our lines. Okay, so in the end of this, because we want to display these lines on top of our panel, and after our button we are going to write them here. So what will we write? First thing, we will catch the height and width of the instruction string that we defined here, so that we won't get short for the space. So self dot inst width equal to self dot instructions dot get underscore width. Same for the height. We are going to do this because we want good space to keep our text. Sometimes we feel that the text is crumbled or it is not looking good, so it is better to get good space. Now we need to define the rect. Self dot inst rect is equal to pygame dot rect. How are we going to define it? I want to display it at the position width by 2, comma height width by 2 minus self dot instruction width divided by 4. Because I want to display them below the button, I calculated these values. You can calculate on your own for the places where you want to place them. Height into 0.6, comma, means we placed x and y is done. Now we want to display the width and the height. Self dot instruction width, comma self dot instruction height. Okay, now we have rect as well defined. Now we again need to draw these, define these here inside the draw. We did this in init, but we need to update them here by self.linex is equal to self.instrect dot x, and same for instruct dot y. Okay, now we need to draw all the lines one by one. For line in self dot self dot instruction lines self dot render text rendered text equal to self dot inst font dot render. What do you want to render? Line, comma true, comma in color white. I want to display it in yellow. I'll do it in yellow. Now surface dot blit surface.plit self.render text, where inside the position self.linex, comma self.line y. Now we need to update the self.line y by increasing line size in it. So self.line y plus equal to self.line size. Okay, in this way we will go to the next line and we will start displaying the next line. We are done with the display part. Let's review. We created the font, we created the lines, we got a good amount of room to display with a good width for our instruction. Then we started to draw them. Okay, now let's try to run our game. So Python multiline instruction.py. Cool. This is how we display multi-line text in Pygame. In the coming session, let's add an HUD that will display the player status, means how much life is left, how many stars are collected, etc. etc. Okay, so till then, stay tuned. Hello everyone and welcome back. In the previous session, we displayed an instruction text on our UI panel. In this session, let's create an HUD panel that will display our score and our remaining lives. Okay, for this we are going to need two images, one for the HUD panel, one for the life. So I am using this heart PNG to represent life. So let's get started. Let's open the project in our code editor. We will be building on top of our previous file multiline instructions.py. Okay, so let's get started. Let's copy all the contents of the file in a new one. Let's paste it and let's save it as making hud.py. So this is also just like the menu panel, but difference between menu and UI HUD is HUD will be all there all the time and menu will be only on the game over part. We will hide HUD on game over, we will display menu on game over. So for this we are going to need a class for our HUD. So let's define a class just like our menu class. So below our menu class, let's define it. Class HUD. Let's extend it with pygame.sprite.sprite, just like menu. We are also going to need images. So I am going to load the function here. I am going to copy the same function, load images, and for this we are going to need HUD panel image, not image, let's call it texture. Image.load. Let's check out what is our HUD panel's name. Panel.png. Okay, and we will also need a texture, hard texture, cls dot hard texture. The same way we will load hard.png, this file. Okay, so we have loaded both of them. Now let's init our HUD. Let's copy the init functionalities here, basic empty structure, and then let's edit it. Def init self super HUD. Okay, in HUD what do we want? We want a panel on top of which we will display the heart, we will display score, and how we will display remaining lives. Okay, so for this, first things first, we are going to need a position for our HUD. So self dot x equal to x. Okay, so here we haven't provided anything in the constructor. We should provide xy position and width and height. By default, let's go with x is equal to 0, y is equal to 0, width is equal to 1, and height is equal to 1. Okay, sorry. Self x is equal to x, self y equal to y, self width, height, let's set that up as well. Okay, now let's define the rect. Self dot rect equal to self dot HUD panel texture dot get rect. Okay, done. And self dot image is equal to self dot HUD panel texture. Okay, done. Now we need to use the heart image as well, right? So let's define the heart. Self dot heart image equal to Pygame dot transform, because we don't know how big is the heart texture, dot scale. Let's scale it down to say 50-50. Self dot heart image comma 50 comma 50. Okay, now we also need two things. One is the text for life, one is the text for score. So self dot core font. Let's copy the font from the above. Pygame.font.font. is equal to pygame.font of font, and let's define some size, say 24. Okay, you can directly provide a number here, or you can define a font size and you can provide that here as well. Okay, now you need to define the text. Self dot score text is equal to self dot score font dot render score inside quotes, score equal to plus str. Now we want uh, score, the star count from our main series. How will we bring that up? Let's define a variable here as parent. Okay, self dot parent is equal to parent, and let's call this parent in the parameters. Okay, so if we provide parent in such parameters, we will use it here. Okay, now parent dot star count. You can directly provide star count also, but I wanted a bit more control, so I used parent here. Okay, now we want to enter 255 comma 255 comma 0. I am using golden color, yellow color actually, not golden. Okay, in the same way we need to draw the life. Okay, so let's copy this. Let's use the same font for it, so that we won't need to change the font size and all. Self dot life text, life text, self dot score font dot render. Now beside this heart we need to draw x into str string self dot parent dot life, life e by 10. Why are we dividing by 10? Because our life is getting reduced by 10. Initially it was 30, then 20, then 10, then 0. So divided by 10. Now we have defined everything. Now let's draw them on the screen. Okay, for this let's copy the draw method from the menu and let's edit it for HU. Def draw self dot surface, so surface dot blit. Now you need to remember the things will get drawn in the sequence, you write them here. So self dot image comma self dot rect. Then once first you draw the panel, the image, then you draw the score font. So self dot score text, so yeah, is equal to this part. Self dot score font dot render score is equal to the parent star count. Then same for life text. Self dot life text is the life. Later, we need to split the score text heart image on the screen and the life text. So surface dot split self dot score text. Where do we want to split that? Let's say towards a bit left side of the screen. So width into 0.2 comma and at the kind of top of the scene. So I'm going to use hard coded 50 here at the 50 pixel. And I also want to draw the heart image on it. So surface dot split self dot heart image comma width into 0.4. You can play with this value to use your favorite places. Okay, the heart image is kind of smaller, so let's change its y position here. Let's check how does this look. We can change its position later as well. Okay, now we also need to draw the life text, and I want to draw it a bit beside the heart image, so I need to calculate the rect for the life text. For this I am going to do text underscore width is equal to self dot life text dot get width, and text height equal to self dot life text dot get height. Now need to define the rect. Text underscore rect is equal to pygame dot rect. Now I want to show my live text a bit beside the heart image. So I'm going to do width into 0.45 comma 50 x and y done. Now width and height. Text width comma text height. Okay. Now we need to split our live text. Surface dot split self dot live text comma text rect. Okay. Why didn't I put it self dot text rect? Because it is going to get updated every time inside the draw. So I didn't put it as self dot text rect. Now we completed our HUD class. We need to instantiate it. How do we do that? First load images. HUD dot load images. Then inside the load assets, let's instantiate it. Self dot HUD equal to HUD. What we need to provide here? First things first, parent. So parent will be self. Then we need to provide x and y position to it. So I am going to provide say 300 comma 300, then width and height 64 comma 64, some random numbers. You can change these according to your requirement later. Okay, now we define the HUD. Now we need to render it. How do we do that? In the render scene, when game over is false, we want to define it. If you want to define it, even if game over is true, means anyways you want to define it, then draw self dot HUD dot draw. And what do we want to give the parameter? Self dot surface. And our pygame.display.flip is already working, so we don't need to update the HUD for now because there is nothing new to update in HUD. Everything is taken care by the draw method. So let's save it and let's check how does our program look. So view terminal, Python, making HUD.py. So here we can see that our panel is kind of small. What we need to do it to stretch it for full screen, we need to transform it like the heart image. Self dot image equal to pygame dot transform dot scale. What do we want to scale? Self dot HUD panel texture to width comma say 300, 200. Okay, now let's run it. Cool. You can see the hearts is getting updated. Now let's increase the score by collecting some stars. In the coming session, let's do storing and retrieving high score in the files, and let's display the high score on the main menu. Okay, so stay tuned. Hello everyone and welcome back. In the previous session, we checked out how to display HUD in our game. In this session, let's add a high score on our UI panel, including let's store the high score in a text file in our game. Okay, so for this we are going to need a .txt file with name high underscore score. You can use any of your favorite name. I used high underscore score .txt. Inside that, let's write a 0 as initial value. Okay, so now let's get started. Let's open our folder inside our code editor. This was our previous file making HUD. We'll be working on top of this file only. So copy all the contents in a new one and let's save it as highscore.py. Okay. For this we are going to need to work on only 3 classes. Let's review the functionalities first. First is we need to save our high score. We need to load our existing high score and we need to update our current high score. Okay. Later we need to display our high score. For this, inside the game over functionality that we wrote inside the animate blast, we will call the update function. update high score function, and inside the menu we will display the function. Okay, so for this, let's first define the functions inside our scene class below our init state. Okay, so now let's first define the save function. Def save high score self comma score. We will be using Python's file operations. So with open high high score dot text in a write operation as file dot write str score. Okay, now let's load existing one. In previously we opened in write mode. Now let's open in read mode. Def load high score self. Try with open high underscore score dot txt in read mode, R for read here, as file return int file dot read. Except file not found error. Okay, in this case return 0. Now we have saved our high score, we have loaded our high score. Now let's update our high score. Def update high score self comma current score. Now to compare the current score, we need to fetch the existing high score. So high score is equal to self dot load high score. If high score, if current score is greater than high score, we need to update one, right? So self dot save high score with the current score, and self dot high underscore score is equal to current score. Okay, now we have defined all the functions. Now let's use them. First things first, let's define our high score here. Self dot high score is equal to self dot load high score. Okay, now let's update the high score. Here inside the animate blast, self dot parent dot update high score. Let's check for the typo. Update high score with self dot parent dot star count. Okay. Now let's display the high score. For this, let's go to the menu class. We will need to define the score text and its rect. Okay. So let's copy the title, rect and text for our reference. Let's put it below our instruction lines and let's rename it to self.score text. Change the width and height to 400 and 400. So I'm going to delete these lines. So width and height of my rect will be 400 comma 400. I'm going to change the position of the rect to um, width into 0.2 and height into 0.5, and I'm going to change the name of the rect to score rect. Okay, so now we have defined our score rect, our score text. Now let's blit it on surface dot blit self dot score text comma self dot score rect. Okay. Now we need to update this draw method inside our render scene with the existing high score. Self dot high score. Okay. Now let's check how does this look. CLS Python high underscore score dot py. Cool. Currently it is 0. Let's check out how does this look after we collect some coins and game over. So you can see current high score is 7. Okay. What if we replay it? Okay. Now let's go to game over. Cool. Our score got increased. Let us close this. Replay this. Let's see if our high score is fetched. Yes, our high score is fetched from the file. So this is how we store the high scores in files in Pygame. In this session, we checked out how to store and display the high score for our game. In the coming session, let's create a sound toggle button inside our HUD. So stay tuned. Hello everyone. In the previous session, we checked out how to display high score on UI panel and how to store it in a text file. In this session, let's check out how to create a sound toggle button in our HUD panel. Okay, so let's get started. For this, I have added two required files inside our folder, and let's open that folder now inside our code editor. This is our previous file, highscore.py. I am going to use the same one to build on top of this. Okay. I am going to copy all the contents into a new file. I am going to save the file as sound toggle dot py. Okay. So for this, first things first, we need to add two images for the sound toggle button inside our HUD. So let's go to HUD class. I have written a variable here, an array variable to load the images. cls.sound toggle button image. Let's copy the loading functionality from above line. Pygame.image.load sound.png, comma, pygame.image.load soundpressed.png. Okay. Now we need to define a rect for our sound button. So inside the init of HUD, let's define self.soundRect is equal to self dot sound button image of 0 dot get underscore rect. Okay. Now I want to set the position of this sound rect. So self dot sound rect dot x is equal to, I want to display it on the top left of the panel. So I am going to add hard coded 100 for x and self dot sound rect dot y is equal to, we will match it with the heart image which was placed at 50, 40. Okay. So now we loaded images, we defined the rect for it. Now let's do one thing, let's split our sound button. But it is a toggle button, so we need to maintain its state. For this, we will do self dot is sound on equal to initially true. Okay. And inside the draw function, if self dot is sound on surface dot blit self dot sound button image of 0 at self dot sound rect. Okay. Else we need to display the other image. Okay. We loaded the images, we defined their positions, we defined their rect, we displayed them on the HUD panel. Now we need to catch the click on the button. For this, let's go to the event loop where we are already catching click on the start button. So on the mouse button up, if self dot, now we need to check the position against the HUD's sound rate. So if self dot HUD we defined above only, dot sound rect collide point event dot post. Since it is a mouse position, it will return us the post. Self dot HUD dot is sound on equal to not self dot HUD dot is sound on. For this, to check this, let's print here. If self dot hud dot is sound on, print sound is on, else print sound is off. Okay, now let's try to run it. Python sound toggle dot py. Okay, I'll move the window a bit aside. Let's click on it. Cool. It is getting toggled. The image is getting changed. In this way, we add toggle buttons in Pygame. In the coming session, let's work on creating custom cursors using Pygame. So stay tuned. Hello everyone. In the previous session, we added a toggle button in our HOD panel. In this session, let's create some custom cursors using Pygame. We don't need custom cursors in our game, so we will create just a reference file for how to create custom cursors using Pygame. So let's open our folder inside our code editor. Let's create a new file and let's save it as custom cursor.py. Okay, let's start typing the code. First things first, import Pygame. Okay, then import sys. Now we need to initialize Pygame. So pygame dot init. This file is going to be a good review file for us since a few practicals we are copying on top of previous files. This file we are writing from scratch. Okay, so pygame init. Let's define a window. Screen is equal to pygame dot display dot set underscore mode. Inside the tuple we need to provide height and width 400 comma 400. Okay, I want to define a fixed height and width rectangle for our display. Now let's set a caption. Pygame dot display dot set underscore caption custom cursors. Okay, now let's define a few cursors to be used here. So for this, let's define a JSON cursor underscore images equal to default pygame dot cursors. Let's use some Pygame cursors internal arrow. Let's define another cursor. Let's say diamond. Diamond pygame dot cursors dot diamond. Okay, and let's define one more cursor cross hair. Pygame dot cursors dot broken underscore x. Okay. Now we defined our cursors. Now let's do one thing. Let's set our default cursor. So for this, current cursor is equal to default. Okay. Now let's set the cursor to our mouse cursor. For this we need pygame dot mouse dot set cursor. From the cursor images, we need to use current cursor. Okay. Now let's go inside the game loop. While true. If you remember, we used to use a running variable here. This time I am using a hard-coded true. Let's catch all the events. For event in pygame dot event dot get, if event dot type equal pygame dot quit. Let's do pygame dot quit, and let's also do sys dot quit here. Okay. Elif, let's capture the let's set the cursors according to our keyboard input now. Elif event dot type equal pygame dot key down. Okay. If event dot key is equal to pygame dot k underscore 1, let's set default cursor. Current cursor is equal to default. Elif event dot key equal to pygame dot k underscore 2, current cursor equal diamond. Elif event dot key equal to pygame dot k underscore 3, current cursor is equal to crosshair. Okay. Now let's set the cursor. Pygame dot mouse dot set underscore cursor to cursor images of current cursor. Okay, we done with this. Now let's fill our window with some white color. Okay, screen dot fill in a tuple color code 255,0,0. If you remember, in the first practical we used a cyan color. Now let's capture the position of mouse. So pose is equal to pygame dot mouse dot get underscore post. Okay. And let's define a rectangle at this position a bit upwards from the mouse pointer. So Pygame dot draw dot rect at the position with color. Let's first define the color on the screen with color of red 255, 0, 0, comma in a rect called post of 0 minus say 15 comma post of 1 minus 15 comma height is 50, width is 50. Okay, done. Now let's update the Pygame display. Pygame dot display dot flip. This will update everything on the screen. Okay. Now let's try to run this code. Oh, suddenly I noticed that our screen is filled with 25500. Let's convert it to 255, 255 and 255. This will give us white color. Now let's try to run this code. You can see my current cursor, right? So let's type Python custom cursor.py. Okay. Now let me change the custom cursor by pressing 3. You can see the broken X, right? This is how we set different custom cursors using Pygame. In the coming session, let's have a look at how sounds work in game development. Okay, so stay tuned. Hello and welcome to the module of sounds. Sounds and music are integral components of game development that significantly contribute to the overall player experience. They enhance immersion, set mood, provide feedback, and create memorable moments within the game. Here are some key roles that sounds and music play in games. First is immersion and atmosphere. Sound and music help create immersive game worlds by setting the atmosphere and establishing game's theme and setting. They bring the virtual environment to life by adding ambient sounds, background music, and realistic audio effects. They make the players feel more connected to the game world. Emotional impact. Sound and music invoke the emotions and enhance storytelling in the games. They can intensify dramatic moments, build suspense, create tensions, or evoke excitement, joy, or fear. By using the right sounds and music cues, game developers can efficiently convey emotions and heighten the player's emotional engagement in the game's narrative. Next comes feedback and game state. Sounds and music provide valuable feedback to the players about their actions and the state of the game. They indicate successful actions such as collecting items, completing objectives, or scoring points. Likewise, they alert the players to the failures such as taking damage, running out of time, or losing a life. These auditory cues help the players to understand the game's rules, progress, and outcomes. Next comes gameplay information. Sounds and music can convey important gameplay information that complements the visual impacts. For example, distinct sounds can indicate the proximity of enemies, the presence of hidden objects, or availability of power-ups. By incorporating audio cues strategically, the game developers can provide players with additional gameplay information and enhance their decision-making process. Next comes immersive soundscapes. Detailed soundscapes immerse the players in the game world by simulating realistic and dynamic audio environments. They create a sense of depth and spatial awareness, allowing the players to perceive the distance and directions of the sound source. Immersed soundscapes contribute to the realism and believability of the game world, making it more engaging and captivating for players. Players' engagement and retention. Sound and music have the power to captivate the players, increase their engagement, and enhance their overall gaming experience. A well designed audio element can make a game more memorable and enjoyable, encouraging the players to stay engaged for a longer period and return for future playthroughs. Next comes branding and recognition. Distinctive sounds and music can become synonymous with a game or a game franchise, contributing to its branding and recognition. Memorable sound effects, iconic music themes, or catchy jingles can instantly evoke a sense of nostalgia and association with a particular game, helping to establish a strong brand identity. Adaptive and dynamic audio. Advanced game audio systems allow for adaptive and dynamic audio experiences. The sound and music can adapt in real time based on the gameplay variables such as players' actions, in-game events, environmental conditions, etc. These adaptive audio enhances the immersion and responsiveness of the game, providing a more personalized and interactive experience for the players. In summary, the sounds and music play a crucial role in games by enhancing immersion, setting the mood, providing the feedback, conveying emotions, delivering the gameplay information, creating immersive soundscape, increasing player engagement, and contributing to the branding. By carefully designing and implementing high quality audio elements, the game developers can elevate their games and deliver more impactful and enjoyable experience to the players. In this session, we checked out why do we use sounds and music in games. Let us check out what are the different kind of sounds and music those are used in games. So, it is coming in the next session. So stay tuned. In the previous session, we checked out why sounds are important in games. This time, we are checking out what are the different game sounds, means what are the concepts of sounds in the game. So let's get started. In game development, sounds serve various purposes and can be classified into different types based on their role and functionality. Here are some common types of sounds used in games. First is background music. Background music sets the mood and atmosphere of the game. It often plays continuously throughout the gameplay and helps to create immersive experience. Background music can vary depending upon the game's genre, location, or specific events. Next comes sound effects. Sound effects are the short audio clips that enhance the game's realism and provide feedback to the player. They can include sounds like footsteps, gunshots, explosions, door opening closing, object interactions, and much more. Sound effects add interactivity, and make the game world feel alive. Next come the ambient sounds. Ambient sounds are environmental sounds that contribute to the game's atmosphere. They include sounds like rain, wind, birds chirping, traffic noises, and any other backgrounds that create sense of place or a situation. Ambient sounds help immerse the player in the game world. Next are user interface, that is UI sounds. UI sounds are the audio cues associated with user interaction and interface elements. They include button clicks, menu navigation sounds, error notifications, confirmation sounds, and other audio feedback that provide a responsive and intuitive user interface. Voice-over and narrations. Voice-over and narrations are recorded spoken lines or dialogues delivered by the characters or narrators in the game. They help convey the story, provide instruction, or add character depth. Voice-overs and narrations contribute to the game's storytelling and character development. Next are musical stings and genre. Musical stings and jingles are short musical compositions used for specific events or actions in the game. They indicate victory, defeat, level completion, power acquisition, or any significant milestones. Musical stings and jingles add excitement and emphasize the important moments. Next is ambient music and background loops. Ambient music and background loops are continuous musical tracks. They play in the background to maintain the consistent audio backdrop. They often blend with the other sounds to create immersive audio environment. Ambient music and loops help to establish the game's tone and provide a cohesive audio experience. Cinematic sounds. Cinematic sounds are used during the cutscenes, story sequences, or dramatic moments in the game. They include orchestral music, intense sound effects, and immersive audio design to enhance the narrative and create memorable cinematic experience. Foley sounds. The Foley sounds are recordings of everyday objects and actions used to create realistic sound effects. They include footsteps, door cracks, glass breakings, or any other sounds that add authenticity and detail to the game's audio design. Finally, environmental sounds. Environmental sounds are specific to the game's surroundings and the location. They include sounds like water splashing, leaves rustling, machinery humming, or any other sounds that bring the game world to life and make it more believable. These are just a few examples of the types of sounds used in games. Depending upon the genre, gameplay mechanics, and artistic direction, game developers carefully choose and design the sounds to enhance the overall player experience and create captivating audio atmosphere. In this session, we checked out what are the various kind of sounds used in game development. In the coming session, we are checking out can we actually create the sounds using a MIDI controller inside the games. So stay tuned. Hello, since we are now looking into the sounds in your game, let's have a look at the concept of MIDI, MIDI, the musical instrument digital interface. So let's get started. Audio plays a crucial role in game development, enhancing immersion and creating a captivating experience for players. Pygame, a powerful game development library, provides support for MIDI (MIDI) to bring dynamic music and sound effects in your game. MIDI is widely used in music industry and offers a standardized protocol for communicating musical information between electronic devices. In general development, MIDI enables the creation and control of music and sound, adding depth and richness to the audio experience. It brings the dynamic music and sound effects to your games. Here are some key points about the role of audio and MIDI in game development. First, music composition and playback. With Pygame's MIDI support, you can compose and arrange music using MIDI files. MIDI sequencers and music notation softwares allow precise control over melodies, harmonies, rhythms, and other musical elements. Pygame enables a real-time playback of MIDI compositions, allowing dynamically generated music based on the gameplay events or player action. Next comes instrument control. MIDI provides standardized way to control musical instruments and synthesizers. Pygame allows you to use MIDI messages to trigger specific instrument sound, change instrument parameters, control volume and effects, and create expressive musical performance in your games. Next comes sound effects and MIDI. Pygame's MIDI capabilities extend beyond music. You can also use MIDI to trigger sound effects in your game. By assessing By assigning specific MIDI events to various sound effects, you can synchronize audio cues with game events, actions, or animations, immersing the players in a dynamic and interactive audio environment. MIDI controllers. Pygame enables interaction with MIDI controllers, such as keyboards, drum pads, or sliders. These controllers allow players to interact with the game by creating music, controlling virtual instruments, or manipulating sound effects directly. Integrating MIDI controllers adds a unique and engaging gameplay element in your game. Next is MIDI file efficiency. MIDI files are compact in size compared to the audio files like WAV or MP3. This makes them an efficient choice for games with limited storage or bandwidth requirements. MIDI files can be easily edited, manipulated, and transformed by providing flexibility in creating dynamic and adaptive music for your games. By leveraging Pygame's MIDI support, you can harness the power of MIDI to create captivating music, control instruments and sound effects, and provide immersive audio experience in your games. Whether it is composing dynamic soundtracks, triggering interactive sound effects, or integrating MIDI controllers, Pygame empowers you to create rich and engaging audio environments for your players. In this session, we checked out the MIDI and Pygame support. In the coming session, we are checking out the mixer module in Pygame, which actually works in playing your sounds and music in Pygame when you are making games using Pygame. So stay tuned. Hello. In this session, we are going to check out Pygame and sounds and the mixer module. Pygame, being a versatile game development library, provides a robust set of modules and functionalities for working with sounds and music in the game. Here is how Pygame facilitates the sound integration and manipulation. The first point is sound playback. Pygame's mixer module allows the developers to load and play sound effects in various formats, such as WAV and MP3. It provides functions like pygame.mixer.sound to create sound objects from the audio file and sound.play to play them during the gameplay. Developers can control the volume, panning, and looping options to achieve the desired sound effects. Next comes music playback. Pygame supports the playback of background music using the Pygame Mixer.music module. It allows the developers to load the music files such as MP3 or OGG and control their playback. Functions like pygame.mixer.music.load and pygame.mixer.music.play enables the developers to load and play music tracks seamlessly. Additional features like volume control, looping, and fading effects are also available. Sound effects and mixing. Pygame provides flexible sound mixing system that allows the multiple sounds and music tracks to be played simultaneously. Developers can create layered sound effects by playing multiple sound objects together, adjusting their volumes, and applying the special effects. This capability enables the creation of complex audio experiences in the game. Next comes sound manipulation. Pygame offers functions for manipulating sound samples, such as adjusting volume levels, applying filters, modifying playback speed. These features allow developers to dynamically alter the sounds during gameplay, creating unique and interactive audio effects. Next comes sound loading and caching. Pygame provides efficient mechanism for loading and caching sounds to minimize the loading times and improve the performance. By preloading frequently used sound effects and music tracks, developers can ensure smooth gameplay without any delays or interruption. Sound positioning and spatial audio. Pygame supports spatial audio by allowing the developers to set the position and orientation of sounds in virtual 3D space. This feature enables the realistic sound positioning, where sounds appear to come from specific directions or locations within the game world. It enhances the immersive experience for players and adds the depth to the audio environment. Next comes sound event handling. The Pygame's event system includes events related to sounds, such as sound playback completion event. Developers can utilize these events to trigger specific actions or reactions in the game, allowing for dynamic sound interactions based on the events or player's actions. Sound formats and codecs. Pygame supports a wide range of audio formats and codecs, including WAV, MP3, OGG, and much more. This versatility allows the developers to work with their preferred audio format and ensures the compatibility across the different platforms and systems. In conclusion, Pygame offers comprehensive features and functionalities for incorporating sounds and music into the games. With its sound playback and music playback, mixing compatibilities, sound manipulation options, spatial audio support, and event handling, Pygame empowers the developers to create immersive and engaging audio experiences in their games. In this session, we checked out the mixer module. In the coming session, we are going to do the practicals related to the sound like adding the background music in our game and adding the sound effects as well as toggling the sound effects on button pressed events. So stay tuned. Hello everyone, I welcome you to the practical of 6th module of Pygame. So in this module we checked out how the sound system works. So in this session, let's try to add some background music in our game. For this, we are going to need a game music file. I'm using gamemusic.ogg here and let's open the folder inside our code editor. This was our previous file where we added a toggle button inside our HUD panel. Let's start working with sound things. So let's copy all the contents into a new one. Let's save it as add music.py. Okay. For this, we need to do is first things first, we need to initialize the Pygame mixer module that we checked out in the previous session. Now, after that, we need to load our game music and finally, we need to play the game music in a loop. Okay. So let's get started. We need to work on the scene class only. So inside the init, let's initialize the pygame.mixer module. Here I have initialized pygame.mixer.init below the pygame.init. Now inside the init state, let's write pygame.mixer.music dot load gamemusic.ogg. Okay, gamemusic.ogg. Now let's play this inside our main loop. Inside the main loop, let's put it here. Pygame dot mixer dot music dot play. Okay, when we provide a -1 here, it will keep playing continuously one after another. So let's try to run it. Python add music.py. Okay, this is how we add background music using pygame.mixer module. In the coming session, let's add some sound effects on catching star or catching a bomb. Okay, so stay tuned. Hello everyone. In the previous session, we checked out how to add game music inside our Pygame. In this session, let's check out how to add some sound effects inside our game on special occasions like collecting stars, bomb explosion, etc. For this, I have added some required sound files inside our project. So let's open our project inside the code editor. This is our previous file. We will use the same file to build upon. So I'm going to copy all the contents in a new file and I'll save it as add sfx.py. Okay. Now we know how to load sound files using the mixer module. So let's add some more sound files using the Pygame Mixer module. We had load this inside the init state. Let's move it to load assets. Okay. So initially we loaded a music. This time let's load a sound effect by pygame dot mixer dot sound is equal to coin 01.ogg. Okay, this time we need to assign it already to some value. So self dot coin sfx. Let's assign this variable to our sound. Self dot coin sfx is equal to pygame dot mixer dot sound coin01.ogg. Now we need to add two more sounds. Self dot bomb sfx to pygame.mixer.sound explosion1 dot ogg, and third is our game over sound. Self dot game over sound sfx mixer dot sound game over dot ogg. Okay, we have loaded the sounds. Now let's do one thing. Let's define this with a variable as well. Self dot background dot background music equal to. Okay. Now let's check out where do we want to play these SFX. Coin SFX, let's play this when we collect a coin. Bomb SFX, let's play this when we collide with a bomb. So let's go to our game loop where we check out the collisions. Here, okay. When we collide, when the player is colliding with star, let's play self dot coin sfx dot play, and when it collides with bomb, self dot bomb sfx dot play. Okay, and inside the game over, let's play here at the game over self dot parent dot game over sfx dot play. Let's check out for typo. Game over sfx, it is the same. Okay. Now let's try to run this. Okay, so Python add sfx.py. Can you hear the sound effect? Cool. This is how we add sound effects inside the Pygame. In the coming session, let's implement the toggle between game music on and off on the toggle button we created in the previous session. So stay tuned. Hello everybody. In the previous session, we checked out how to add sound effects inside the game. In this session, let's try to toggle the background music inside our game. Means if our sound is on, it will play the music. Otherwise, it will pause the music. Okay. So let's open our project inside our code editor. This is our previous file, add sfx.py. Let me copy all the contents inside a new one. I'm going to save it and call it as sound toggle.py. Okay. Now, for this we are going to need only two classes. First is our HUD class where our button is present, and our main scene class where we will call the function to toggle the functionality of sound. For this, let's create a define to toggle the music functionality. So def toggle sound self. Here, let's toggle inside the method itself. So self dot is sound on equal to not self dot is sound on. Okay. Now, if self dot is sound on, what we need to do is pygame dot mixer dot music dot unpause. Okay, this will continue playing the music. Else pygame dot mixer dot music dot pause. Okay. Now let's call this method where we checked the click functionality of the toggle sound button. So inside our event loop here. So instead of this long functionality, let's do self.hud dot toggle sound. That's it. Now let's try to run this. View terminal, Python sound toggle.py. You can see the music is getting paused, right? When I click here, the music stops. When I click back, the music starts. So this is how we handle the mixer module to pause and unpause the background music of the game. So now we have completed our basic game using Pygame. Now if you want to add, you can add your favorite functionalities in here and you can export in a playable version that you can share with your friends and family. In the coming session, let's wrap up and let's review what we learned throughout this course. And in the practical of the next module, let's create an executable file .exe that will run on a Windows system. So stay tuned. Hello everyone and welcome back. Congratulations, you completed the course. You started with fundamentals and in the previous session you implemented sounds in the game. So, how are you feeling? I really congratulate you to complete the course. Now you are free to create your own games. Now, let's do one more thing. Let's convert our game into an executable file from Pygame to exe that will install on your system and you can share the game with your friends and family. So in the coming practical, let's do that. So stay tuned. Hello everyone and welcome back. In this session, we are going to export our game to an exe file that can be installed on your Windows system. For this purpose, what we need to do is we just need a tool called as PyInstaller installed on your system. So let's get started. Let's open our folder inside the code editor. Our previous file was soundtoggle.py. I copied all the contents in a new file called as finalgame.py and I have made some visual changes. You can also do the changes according to your requirement and then let's convert it into an exe file. For this, we need the PyInstaller. How do we install that? Pip install PyInstaller. Okay. This will check if it is already installed on our system or not. If it is already installed, then it will give us an outcome that it already exists in our system. Requirement already satisfied. That means it is already existing on our system. Now what we need to do is we need to create a spec file for our project. So for this we need to type py dash make spec dash dash one file from our final game.py. Okay, so it created a final game.py. Now we need to make it executable. How do we do that? PyInstaller our spec file now. Final game.spec. So it is compiling the file into an exe. This is the easiest way to convert a Python file into an exe file. Okay, now it is saying it is completed successfully. Let's check out our project. Okay, we got two folders created here. One is build, other is dist. Okay, inside the dist we got the final game.exe. Let's check out by running it. It didn't do anything. It got crashed. Why? Because it didn't file the required files inside it. So we need to copy all the images and sounds and the other assets inside the folder. Let's copy them from this to dest and our font and the high score text file as well. Okay, now let's try to run it. This is how we create an exe file from our Pygame file. You can share this file with your friends and family and enjoy the game. So I hope you liked this course and you enjoyed working with the projects I shared with you. Now it's your assignment or it's a task for you to create as many games you want to create in using Pygame and share with me. My name is Prachi. I am happy to be your instructor. All the best for your future. Thank you.